All right, section 4.2, we're talking about the unit circle in pre-calculus 30, and I'm going to go over some homework questions with you. So question number 2 says, is each point on the unit circle? How do you know? So we're going to have to show our work here and figure out. What we could do is, because you have your unit circle that you just created here, you have a bunch of important points on the unit circle. This is not all of them, though. As you can see, there are many points in between that we don't know the coordinates of. We just know some of these important points. So I guess for this question right here, it looks like, here we go. Letter E, negative root 3 over 2 and negative 1/2. I can see that I've put that point on my unit circle right here. So that is on the unit circle. Now you can say it's on the unit circle that I drew, but here's how you would approach this question. You would use the equation of a circle, which is x squared plus y squared equals 1. That's the equation of the unit circle. Okay, unit circle equation. And you would simply plug in your x and y values and see if the equation is true. All right, so we're going to do that for each one. It's not going to take a whole lot of time here, but negative 3/4, let's try a squared, plus 1/4 squared equals 1. So obviously when we square a negative, it becomes positive. So this is 9 over 16 plus 1 over 16 equals 1. So when we add these together, we get 10 over 16 equals 1. Is that true? No, that's not true. Okay, so that's not true. So it looks like that A is not on the unit circle. Not on the unit circle. And if we were to go to our little chart here, negative 3/4 would be somewhere around here. And then up 1/4, well, see, here's up 1/2, so 1/4 would be like right about here. So that point right here is clearly not on the unit circle, even from a sort of a geometric point. All right, but that's how you know. All right, so let's do B. I'll do B with you here. We'll just do a kind of a sample of some of these questions. So B, root 5 over 8 squared plus 7 over 8 squared equals 1. So let's see what happens when we multiply this out and solve this equation, or evaluate both sides here. Root 5 squared is 5. 8 squared is 64. 7 squared is 49. And 8 squared is 64. Equals 1. So 5 plus 49 is 54. 54 out of 64, does that look about right? Root 5, 7 is 49, 64. Okay, so does 54 over 64 equal 1? No. So it looks like we're struck out with B as well. All right? So you would do this to each question number 2. And again, it won't take too long, but you want to see if you have 1 on the left side as well as the right side. So that's number 2. Any questions about number 2? Okay. Number 3. Number 3 says this: determine the missing coordinates for all points on the unit circle satisfying the given conditions. Draw a diagram to support your answer. Okay, so we need to determine the missing coordinate. I'll just do one sample here. I'll just do A with you. So I have a value of 1/4 for x, and I also have a missing value of y. So let's just go to our unit circle. 1/4, here's 1/2 or so. 1/4 would be about here. So I'm looking for this point right here on the unit circle. See that? That's the point I'm looking for. And the key to finding that missing y value is the equation of the circle. So I know that 1/4 squared plus y squared, whatever that y is going to have to equal 1. And because we're in quadrant 1, that means I have a positive x and a positive y. So my y, when I'm all said and done, has to be positive because it's in quadrant 1. All right, so this is 1 over 16 plus y squared equals 1. Y squared equals 1 minus 1 over 16. Well, what is 1 as a fraction of 16? Well, that's going to be 16 over 16. So y squared equals 15 over 16. the square root of both sides. 15 is not a perfect square, so I'm just going to write that as square root of 15. But the square root of 16 is actually 4. And again, y needs to be positive because it's in quadrant 1. So it looks like y equals the square root of 15 over 4. Okay, so that's the correct answer for number 3. Let's take a look at number 4. If P of theta is a point on the intersection of the terminal arm of angle theta and the unit circle, so it's just, we have a unit circle here, and this is a point that's on the unit circle. Determine the exact coordinates of each of the following. Okay, so in our unit circle, P of theta means the point that is associated with an angle of theta, of pi. So 1 pi is exactly halfway around, remember? So what's the point on the unit circle that is associated with pi? Well, we go back to our unit circle here, right? And we're going to go all the way around pi units. That's here. And so what is the point here on this right here? Negative 1, 0. Elliot?
Why would you start there when you do your rotation?
Why would I start here?
Yeah.
Okay, that's a good question. So standard position for an angle, remember we learned that in 4.1? That's where we have the angle is right here, right? It starts on the x and it goes up this direction. So yeah, in counting pi units for an angle, we always start on the positive x-axis there. Yeah. Oh. So we're looking for this point, which of course is negative 1, 0. And you can just use that from that unit circle that you drew. Okay. Now, P of negative pi over 2, again, we always start from here, our positive x-axis, and we're going to go negative this way in this direction, right? And we're going to go around until we hit pi over 2, which is the same as 90 degrees. So now we're looking for this point. And on our unit circle, we know that this point is 0, negative 1. All right, so that's kind of an introduction number 4 there. Is that good? Any questions there? Okay, I'll do one more with you, just an example from number 5. I'll do some of number 5 for you just so you can kind of get an idea of how to do that one. Number 5 says identify a measure for the central angle theta in the interval 0 to 2 pi. So that means within one full rotation from 0 all the way to 2 pi. So somewhere in here. Identify a measure for a central angle such that P of theta is the given point. Okay, so it looks like all of these are going to come from your unit circle. Okay, all of these are going to be on your unit circle, and we've plotted all of these points. So we just have to figure out what angle that refers to. Okay, so 0, negative 1, well, we just did that one. That's going to be, now it's got to be from 0 to 2 pi. So I'll make this a little bit bigger. Okay, 0, negative 1 is this point right here. So we got to go 1 pi over 2, 2 pi over 2, and 3 pi over 2. So this angle, and you can just count multiples of a known angle that you have on your unit circle. So this is 3 pi over 2. So theta equals 3 pi over 2. C, let's do C. So C is root 2 over 2. They're both positive. So that's going to be this one right here. And that angle is what? What angle is that for C? Anybody? Okay, 1/4, and then what did you say? 45 degrees. Okay, so it's 45 degrees. You see this interval here? It mentions 2 pi, so we're going to put our angle in radians. Okay, so 45 degrees is correct. 1/4 is close. It's 1/4 pi, so it's the same as pi over 4. Yeah, so you were both Really close. Okay, good guesses. That's pi over 4. Perfect. Now, remember this 1 over root 2 simplified is actually root 2 over 2. So that's this point that we put on our unit circle. And where is that? Let's see, negative root 2 over 2 positive. It's going to be over here somewhere, right here, right? Okay, so the angles associated with these. Let me just pause for a second. Okay, so just to finish this question off, what you see is we see that here is the point in this question, okay? Now, it's asking for what angle is this from here all the way to here. And what we're going to do is we're going to fill in the values for this unit circle here for the angles, which we haven't talked a whole ton about here yet. But what I want you to see is that this point right here is connected to this 45 degrees over here, right? Or pi over 4. So this is the way you want to look at this. You want to look at this as being, and I'm going to use this right here. So you want to look at this as being one, oops, that doesn't come across very well, as one section of pi over 4, two groups or sections of pi over 4, and 3 sections of pi over 4. So that's a multiple of pi over 4. It's actually 1 pi over 4, 2 pi over 4, and 3 pi over 4. So the angle that is associated with this point is 3 pi over 4 radians. So for D, the angle is 3 pi over 4. All right. So as we look at the unit circle up here, guys, these are the angles that are associated with these important points that are on the unit circle. What I haven't done here yet is put on my quadrantal angles. Quadrantal angles are the angles that have terminal arms on the x and y axes. So I did label pi over 2, but obviously this over here is pi, an angle of pi right here. And this is 1 pi over 2, 2 pi over 2. This is 3 pi over 2. This angle here, 3 pi over 2. And this would be 0 and 2 pi. Okay? So those angles are going to be very important as well when you're doing your calculations and questions on the unit circle too, okay? All right, and that sort of finishes that number 5 that I was telling you about. So number 5b, okay? So an angle between 0 and 2 pi that has a point 1, 0. Well, that's this point right here, 1, 0. And so that's going to be, that's actually going to be, the answer is 0 because 2 pi, notice, 2 pi is not included in this interval. It includes 0 and all the way up to, but not including 2 pi. So the answer here is 2 pi for B. Okay? So again, that's just some samples for the first 5 questions. Well, for 2 to 5 anyways, for 4.2.